Welcome to gradient separations. So we've already seen in earlier sections that a solvent gradient can improve the separation of various components in a chromatogram without the analysis taking an overly long time. That is, we can change the solvent strength at programmed times during a run in order to shorten the analysis time while still maintaining reasonable resolution. So the dwell volume is the volume between the point at which solvents are mixed and the beginning of the column. The dwell time, TD, is the time required for the solvent to reach the column. That is, the dwell time is the time required for the dwell volume to enter the column. So TD is equal to dwell volume divided by the flow rate. Now, differences in the dwell volume between instruments means that a gradient that works on one instrument is not necessarily applicable to another instrument. The fastest way to determine whether a sample should be separated using a solvent gradient is to run a broad gradient, for example from 10 to 90% acetonitrile. The gradient time, T sub G, is the time over which the solvent composition is changed. And here we have one example. In this case, TG is 40 minutes. Now let's call the difference between the first and last peak in the chromatogram delta T. And in this case, delta T is 21.5 because we have our first peak coming off here and our last peak coming off there. A gradient should be used if delta T divided by TG is greater than 0.25, and isocratic elution should be used if delta T over TG is less than 0.25. That is, if all the peaks are removed over a narrow solvent range, then isocratic elution is reasonable. If not, then isocratic elution will take too long and a gradient elution should be used. If isocratic elution should be used, then a good starting point is the solvent composition halfway between the first peak and the last peak. So in our example, delta T over TG is 21.5 minutes divided by 40 minutes, which is 0.54, and that is greater than 0.25. And that means that a gradient should be used. So we've already run a broad gradient on our sample from 10 to 90% B. If the separation obtained is good enough and the analysis time is acceptable, then we have our method. The separation here is fine, except the analysis time is 36 minutes, which is pretty long. So we want to see what we can do to shorten that. So in our example, the dwell time is 5 minutes, which means that after we've changed the solvent composition, it's 5 minutes before the column actually sees that gradient. So the solvent composition at the column as a function of time is shown here. The first peak was eluted at 14 minutes, which was there. Now, at that point, the solvent composition at that time was 28% B. And the last peak was eluted at 35.5 minutes, which is over here. And the solvent composition at this point is 71% B. That is, we don't really need the portions when the solvent composition is between 10 and 28. We don't really need that portion there. And we don't need the portion between 71 and 90%. So let's try a run with a gradient of 30% to 82% over the same 40 minutes. So we've got our next chromatogram here. The peaks are spread out some, and the analysis time is reduced to 32 minutes. So now let's try a run in which we vary the composition over a shorter time, meaning a steeper gradient. So here, we now have varied the solvent composition from 30% to 82% B over 20 minutes instead of 40. The resolution, however, has suffered. Note here that peaks 6 and 7 are coming off overlapping, and thus we should use that second gradient, that 30% to 80% B over 40 minutes. If a smooth gradient does not provide adequate resolution at a reasonable analysis time, we could use a segmented gradient. Now in a segmented gradient, the solvent composition versus time curve has multiple segments, as we see here, in which the gradient changes at different rates and may be isocratic for some segments. It's isocratic here and there and here. If the segmented gradient does not provide adequate resolution at a reasonable analysis time, we can then change the solvent, use a longer column, use a smaller particle size, or change the stationary phase. And that was gradient separations.